Okay, here are the notes for Identities Part 4. Copy them down, don't just watch this. Notes, Identities. Part 4. Okay. Give you a couple of seconds to copy that in. Copy it down, don't just watch. Okay, so before we get into doing these newer problems, they're actually not new. The mathematics is not new to you. It's just that they're not using numbers, right? They're using these functions, sine, cosine, tangent, and then your understanding of identities. Okay, so let's review. The last time the problems had, we were doing addition, adding fractions and subtracting fractions. They had a common denominator, but they're not. They're not going to be, you're still going to be adding fractions, but they're not going to have a common denominator. 2 over 3 plus 1 over 5, here's an example, right? Just with numbers. 2 over 3 plus 1 over 5, you couldn't add this. Not the way it is now, not like this with these are not common denominators. We need to get a common denominator. Well, when it's numbers, you can find the, least common multiple and then kind of do it that way. Let me zoom in a little bit here. And sometimes when you just can't find it, that you can just simply do what? 2 over 3 plus 1 over 5. Well, I know that the denominator has to have a 3, and I know the denominator has to have a multiple of 5. So I could just multiply this one by the 5. And if I multiply the bottom by 5, you multiply the top by 5. And this one, it's 5, but I need a 3, so multiply this one by 3, right? Multiply the 3 to this one, or with this one, that's 3 times 5. Multiply 5 times 3. And they multiply to 15, right? So they'll be common. And then you'll be able to continue and finish this problem, right? Because now you'll have, right, 3 times 5 and 5 times 3, the same thing, we get 15. See, that's your first objective when adding, subtracting fractions. Make sure you have a common denominator. If they were already the same, you would just do the operations on the top, right? Either adding or subtracting. So here you're going to get 2 times 5, 10 over 15. Here 1 times 3, 3 over 15. And then your answer is what? Well, when you're adding or subtracting fractions, you want to make sure that's a common denominator. Why? Because we keep it. We don't change it. You better not add it. And then you do whatever's left here, right? 10 plus 3, well, 13. Okay. Same thing here for identities. All right, so let's go. Number 1, let me try this one here. What if I have 1 over sine minus 1 over cosine? One over sine and 1 over cosine, we can't do this because they're not common denominators. We need to find the common denominator. Well, we're gonna pretty much do the same thing we did here. Right, I need a 3 and I need a 5, so the 3 gets multiplied by the 5 gets multiplied by the 3, and then they'll end up being common, right? So the same thing you're going to do here. All right, 1 over sine minus 1 over cosine. Well, this one already has a sine. I didn't multiply top and bottom by cosine. And this one already has a cosine, so I got to multiply by sine, top and bottom. Sine sine. And remember, this is a subtract, right? What's left? We got cosine over sine times cosine. They don't give you a product. They don't cancel, right? We leave it in sine and cosine. Sine, just leave it as sine cosine. And then remember, sine times cosine is the same times cosine times sine. So let's just write it the same. I like to write the sine first. So the denominators are going to be the same here now, right? Sine cosine minus, and then what's 1 times sine? Well, that's just sine. All right. We got the same common denominator. We keep it, so we just write it 1 times sine cosine. And then you do whatever the operation is in the numerator. Well, in this case, it's cosine minus sine. Well, you cannot add those. Those are not like terms. You cannot subtract them. They're not Pythagorean, right? You always look for Pythagorean only when they're squared. Pythagorean identities. So actually, that's it. This one stops here. All right, number 2. All right, you can pause it, you can rewind it, you can watch the whole thing over. Number 2. Number 2 is going to be sine over cosine plus cosine over sine. Well, again, we do not have a common denominator. We need to get a common denominator. We need a common denominator. Cannot add this. This is a cosine, this is a sine. Make sure you always work in sine and cosine. So let me copy it again. Right, if you need to pause it to catch up on the writing, well, you can do that. All right, pause it if you need to pause it, and then push play. So, well, I need one of these and I need one of these. The common denominator is a sine and a cosine. So this one needs to be multiplied by sine. And whatever you multiply on the bottom, you multiply on the top. This one already has a sine, needs to be multiplied by cosine, right? And again, sine times cosine or cosine times sine, it's the same thing. So let's write it again. Like I said, I like to write sine first. Sine times cosine, what is this? A plus, and again, sine times cosine, right? We got the common denominator. And what do we get here when we do this plus this? Well, sine times sine is sine squared. Cosine times cosine is cosine squared. Continuing. That's going to give us, now we can write this under this same denominator, right? Now we can add them. We write the same denominator. Sine cosine on the bottom, and this is sine squared plus cosine squared. Ooh, that's one of your Pythagorean identities. Remember that? Which one is it? Pythagorean identity. Well, it says, if you look at your sheet, it says that sine squared plus cosine squared is equal to, or can be written in what other form? Sine squared plus cosine squared, or cosine squared plus sine squared is 1. So what could we put here instead of sine squared, cosine squared? 1. So that's 1 over what? Sine cosine. Okay, a couple more. All right, if you need to pause it or rewind it. Okay, that was number 2. Number 3. One over sine plus cosine. 1 over sine plus cosine. Well, I have a numerator and a denominator here. I don't seem to have a numerator and a denominator here, but we know how to make that a fraction, right? That's 1 over sine plus what? Cosine over 1, right? Just like a whole number, like if it was a 5, you could put 5 over 1. I want to see fractions. I need to see what's in my numerators and then what's in the denominators. I need to see what's in the denominators and what's in the numerators. Now, what's going to be your common denominator? This does not have a common denominator. Sine. Sine is your common denominator. There's already a sign here. I'm not going to change it. This one needs to have a sign. So multiply top and bottom by what? Sine. So you'll have 1 over sine plus, and again I like to write the sign first. Sine cosine is the same as cosine times sine over what? Sine. Concern yourself and just worry about getting common denominators. Don't go backwards here and cancel this out. No, leave it. So we leave what? We have a common denominator, that's sine, so we could just write it once. Now we can combine this and add it, right? Sine is the common denominator, and then what's left up here? Well, 1 plus sine cosine. And can't do anything else with that. That's number 3. Okay, last one, 4. Number 4. One over cosine minus cosine. While this looks almost similar, but it's gonna actually work out different, so don't assume, just do the work. Okay, this is going to be well, we can put a 1 under this, right? Let's just save ourselves some time there, and let me write it again. Common denominator has to be what? Well, cosine times cosine times cosine. You'll be left with this. 1 over cosine minus cosine squared, right? Because cosine times cosine is cosine squared over 1 times cosine is cosine, right? We want this common denominator. We got it. We got the common denominator. It's cosine. That's the main deal. Now, what is left in the numerator? 1 minus cosine squared. 1 minus cosine squared. Don't think this is the answer. 1 minus cosine squared. I know something about squares and ones. I got to check if this is a Pythagorean identity. It is. Is this a Pythagorean identity? Well, remember, when you look at your formulas, it's not going to look like this, but one of them you can change to look like this. You got to ask yourself, which one has the cosine squared? Which of the formulas has a cosine squared from the Pythagorean? This one. Sine squared plus cosine squared, or cosine squared plus sine squared is equal to 1. Well, like I said, I like to write the sine squared first. Sine squared plus cosine squared equals 1. Can I move something so that in one side of the equal sign it says 1 minus cosine squared? Yeah. Here's already the 1. Don't move the 1 this way. If you move the 1 this way, the 1's negative. I don't want the 1 negative. The 1's positive, the negative is on the cosine squared. Well, that's going to make sense. When I get this positive cosine squared and I move it that way, it'll say what? Equal to what? 1. The 1 is already there. Minus what? Cosine squared. So this left this side. Now it's over here. 1 minus cosine squared is equal to what? What's left here? Sine squared. So what is 1 minus cosine squared equal to? What's an equivalent form of 1 minus cosine squared? Sine squared. So here, instead of 1 minus cosine squared, you'll write sine squared. Write sine squared. And then the cosine is still your denominator. That's the answer. All right, practice these, have questions ready, look at it over, and understand it well. All right, thank you.